Good morning, everyone. Welcome to the EasyPower Thursday webinar series. My name is Jim Chastain. I'm your host for today's webinar. Our topic today is the much anticipated release of EasyPower 10.4 and the feature set including single-phase short circuit and arc flash. Welcome to one and all. Before I introduce our guest speaker, as we are in the habit of doing, I'd like to launch a couple poll questions to get some feedback from the audience before we proceed. Here's what the poll questions are going to look like. We do appreciate your participation. There's no obligation or liability, but the feedback will be useful in focusing the material. So how often is single-phase modeling required in your business? I'm frankly real interested in this because it has been a feature that's been requested for some time from a customer base, and we're excited about being able to fill that void. Looks like we're close to a quorum. Let's leave this open for another 10 seconds. Please respond if you haven't done so. Thank you for attending today, and thank you for participating. Here's how folks have weighed in on this. Looks like it's a fairly good distribution, not a little surprising. And then the second question is, what type of equipment would you expect to see in a single-phase system? Again, this has been the result of a feature request from a number of customers, and I say that because EasyPower is very responsive to feedback from customers, tool users alike, and if you have a recommendation on potentially a future feature in the future, by all means send an email to techsupport@easypower.com and say, hey, here's a good idea. What can you do to get it on the list? All right, we're close to a quorum. Let's leave this open another 10 seconds. And we do appreciate your feedback. Here's how folks have weighed in on this. Excellent. Very much appreciate your feedback and the participation. And let me get around to introducing our guest presenter. Our guest speaker today is Mr. Craig Moton, a seasoned veteran of power system design and analysis. He's a registered professional engineer and the lead trainer here at EasyPower. Now, we've pre-recorded Craig's presentation so that he's able to monitor and respond to incoming questions real time. So by all means, submit questions through the question box in the control box for the webinar, and he'll be able to answer those both in person and then after the video, be able to address anything that needs expanded explanation. So at that point, let me kind of hand the presentation off to Craig.
Thank you, Jim. In this webinar, I will review the key 10.4 release changes to provide you with an overview of the impact these changes will have in your use of EasyPower electrical system software. EasyPower now supports single-phase modeling on the one line. This includes single-phase taps from three-phase equipment using a line-to-line or line-to-neutral connection, taps from single-phase three-wire equipment using a line-to-line or line-to-neutral connection, for example, a 120/240 volt connection. Short circuit calculations including reports and equipment duty analysis, arc flash calculation including reports and labels, protected device coordination and TCC plots, and device load calculations. In this first segment of this webinar, I will demonstrate how to build a one line with single phase equipment. On the EasyPower screen is the single phase model I'm going to construct. This is the tutorial single phase one line with the version 10.4 software. The top bus is a 40 volt Y/277 volt three-phase four-wire bus with two feeders. One, a 277 volt line and neutral connection, and a second, a 40 volt line-to-line connection to a transformer with a single-phase three-wire center tap that feeds a panel and 2 horsepower single-phase motor. The key steps to building a one line include inserting single-phase equipment, making connections of various wire configurations, and setting the service type for single-phase equipment. The dialog boxes for single-phase buses, panels, ATS, and sources have an option called service. You can select the service to be single-phase 2-wire or single-phase 3-wire. This property can be changed only when the equipment is disconnected from downstream equipment. In EasyPower version 10.4, 3-phase buses, panels, ATS, and sources also now include a drop-down for service, where either 3-phase 3-wire or 3-phase 4-wire can be selected. To build the single-phase model for this demonstration, I will move to a file that I've preloaded with a utility component for the new one-line. The EasyPower palette has been, and the Insert tab have been modified for release 10.4 to include 2 sections, a 3-phase collection of icons and a single-phase collection of icons. From the Equipment palette or the Insert tab, I will ensure the 3-phase palette is selected and then drag a bus to the one line to connect to the existing utility component. We will refer to the Equipment palette for the remainder of this webinar, but the steps are essentially the same for the Insert tab. I will double-click on the bus symbol to open up the bus data dialog box, and then you will notice that the bus base KV has been set to 0.48, inherited from the utility component. You will also notice that the service type has defaulted to the 3-phase 4-wire. Now I will add a single-phase cable, line of neutral load, and a breaker to the one line. To add single-phase equipment, I will first select the single-phase tab of the Equipment palette. I will then drag a cable from the Equipment palette. The text 1 phase will appear next to the cursor to indicate a single-phase component is being added. The 3-phase equipment does not show any text with the cursor. I will connect the cable to the 40-volt bus that I've added. When I connect the single-phase cable to the 3-phase bus, the Select the Phase Connection dialog box is displayed. This is a very important step. It will indicate to the software the single-phase connection I would like to establish. The possible single-phase line-to-line connections are AB, BC, CA. The possible single-line connection, the single-phase line-to-neutral connections are AN, BN, CN. I will select AN for this connection. EasyPower provides a unique phase connector symbol at the point of connection. This symbol indicates that the phase or wire configuration is different than the upstream bus. You can hover over the phase connector symbol to display the connection type. Next, I will insert a single-phase load to connect to the bottom end of the cable. Upon connection, EasyPower automatically inserts a bus between the cable and the new load. The new bus is automatically assigned the base KV of 0.27 kV to reflect the line of neutral connection tapped off at the 3-phase 4-wire 480-volt bus. The bus obtains its service type of single-phase 2-wire from the configuration. I will double-click on the cable to open up the cable data dialog box and enter the following specifications. I will change the size to 4/0 is the only change I need to make on the top row. And then I will insert the 75 foot for the length of the cable, and then I will calculate to derive the impedances. I will enter the load data on the specification tab for the load. I will select the units to be kVA and power factor and insert that the kVA is 50 and the power factor is 0.8. I will now insert a single-phase low-voltage breaker in line with the cable and just below the phase connector symbol. I will enter the low-voltage breaker data dialog box to enter the specifications. I will select the breaker manufacturer to be generic, and the breaker style to be 225 amp frame. I will select the short circuit tab and press calculate to import the interrupting KA from the device library. And on the phase trip tab, I will enter the desired settings. The frame will be selected as 150 to 225 amp trip. The trip amps will be set at 225 and the instantaneous will be set on high. I will now add a single phase transformer panel to the 3-phase bus. I will drag over a single phase 2-winding transformer from the single phase pallet and connect it to the 3-phase bus. The phase connection dialog box will open automatically. I will select BC for this single phase 2-wire connection line to line to the transformer. Note that the transformer automatically gets the voltage rating of 0.48 kV on the primary side, since this connection is line to line at the 3-phase bus. The top right of the transformer data dialog box, there is a checkbox for center tap connection. I will select the checkbox to make the transformer secondary a center tap connection. This specifies the transformer has a grounded, neutral, center tap secondary winding, making the service 1-phase 3-wire for downstream buses as depicted in the slide. Note that if you do not check this box, the transformer secondary is treated as single-phase 2-wire line to neutral service as shown in the top winding connection on this slide. I will enter the following in the transformer specification details. I will select the transformer to be a dry type transformer with a 150 C temperature rating and rated kV on the secondary side at 0.24 and the kVA as 50. On the impedance tab, I will enter 2 for the %Z and press calculate to import the XR ratio from the reference data in the software. I will drag a single phase panel from the single phase equipment pallet and connect it to the secondary side of the transformer. I will double click on the panel to view the connection data. The base kV of 0.24 is inherited from the transformer. This is the line to line voltage. The panel also inherits a line to neutral base kV voltage of 0.12 kV, consistent with the line to neutral voltage of the single phase 3-wire center tap transformer. The service field shows that the panel bus is a single phase 3-wire, also inherited from the transformer connection. The blue icon indicates that the panel must be disconnected to change the service. I will click on the description tab in the panel data dialog box to open the panel schedule spreadsheet. I will select 6 for the number of rows and then press OK. This creates 6 rows in the spreadsheet to fill out the branch circuit data. In the spreadsheet, I will enter the load data as shown. In the column named circuit breaker / fuse poles, I will enter 2 in row 1. This makes the first circuit a 2-pole circuit, rows 1 and 3, for which the load voltage is 0.23 kV, and the load will be 2000 VA split equally between the load VA columns VA-L1 and VA-L2. This creates a 2-pole balanced load. On row 5, I will leave the row set as a single pole, and I will enter 0.12 as the voltage. I will then enter 500 VA under the VA L1 column. I will close the panel data dialog box for now. In order to get arc flash data for the panel, I will now insert a single phase low voltage breaker on the primary side of the transformer and then enter the following data. I will select the breaker manufacturer to be generic and the breaker style to be 225 amp frame. I will select the short circuit tab, press calculate to import the interrupting KA, and on the phase trip tab, I will put in the desired settings. I will select the frame to be 225 150 to 225 amp trip, and this time the trip amps will be set at 150 and the instantaneous on low. Now I will add a single phase motor to the panel. I will first add a 120 volt circuit extending from the single phase panel. I will insert a single phase cable starting from the panel and extending downward. The phase connection dialog box is open automatically since there are several connection options. For a single phase 3-wire system, you can connect single phase 3-wire equipment, also referred to as LLN, single phase 2-wire line-to-line connected equipment, referred to as line-to-line, and single phase 2-wire line and neutral connected equipment, referred to as LN, using the L1 or L2 hot conductors in neutral. These connections are given the designations L1N and L2N. I will select L2N for the connection to the 120 volt single phase motor. A single phase motor is connected to the bottom of the cable. EasyPower automatically inserts a bus with the base kV of 0.12 kV, which is inherited from the panel line and neutral base kV. I will double click on the phase connector to verify the L2N connection as selected. I will set the following cable parameters for the subpanel feed. I will set the conductor size to be number 4 AWG, the length to be 50 feet, and then I will press calculate to bring in the impedances for the cable. I will make note of the cable ID name since it will be used to specify the subpanel connection in the panel schedule. I will open up the motor data dialog box and set the horsepower to 2. The kV of the motor is automatically selected to be 0.115 kV due to the 0.12 kV nominal system voltage. On the short circuit tab, I will press calculate to import the X to R ratio from the reference data used by the software. I will open the panel again to specify the single phase 2-wire subpanel connection. On the description tab, I will select the row 7 load type column to be subpanel and the subline to be C2. I will find the device edit column in the protected device section of the spreadsheet. You can also use the protected device tab at the bottom to more quickly move to this section. I will click on the data button to display the low voltage breaker data dialog box and enter the following data for the breaker to protect the motor. Manufacturer will be set to generic and the breaker style will be set at 50 amp frame. On the short circuit tab, I will press calculate to import the short circuit rating, and on the phase trip tab, I will enter the following data. I'll select the 50 amp frame and then I'll set the trip amps to 30. Pressing the summary tab in the panel data dialog box, I can now see the demand load calculation for the single phase panel. If I select calculate downstream load, you will notice a message box will pop up warning the code design KVAs in the current panel will be updated. I will select OK to continue. The panel demand load calculation, including the downstream load in the right-hand column, will be displayed. For the TCC analysis, later in this webinar, I will now add a service entrance circuit breaker to the utility connection. I will first select the 3-phase equipment palette. and then drag over a three-phase low voltage breaker in line with the utility. I will enter the following data for the low voltage breaker. I will select the manufacturer to generic and the breaker style to a 400 amp frame. On the short circuit tab, I will press calculate to import the interrupting KA. And on the phase trip tab, I will enter the breaker settings. I will select 400 amp trip. The trip amps automatically comes up, and I will set the instantaneous to 4,000. This completes the creation of the one line. In release 10.4, MCCs are three-phase only, but can now have rows programmed for single phase. So the three-phase bus in this one line example could have been constructed using the MCC equipment type. With the one line construction complete, I can now perform short circuit analysis on the single phase model. On the home tab, I will click the short circuit button to enter the short circuit focus. I will fault all buses to display the short circuit currents. Make note that the fault current for panel 1 is 13.75 kA. For a single-phase 3-wire panel that is fed by a center tap single-phase transformer, you can get different results for line-to-ground or line-to-line faults. The line-to-ground fault current will be higher than the line-to-line fault current for a single-phase 3-wire center tap transformer when the fault point is close to the transformer. EasyPower provides the ability to select your choice of single-phase fault type in the Control tab of the Short Circuit Options box. I will change the single-phase 3-wire fault type to line-to-line, and then select Apply at the bottom right of the box to apply that change. The revised short circuit current of 8.4 kA is now shown for the panel, this being less than the line and neutral selection for fault type. I will reselect line and neutral fault for the single-phase 3-wire fault type for the remainder of this webinar discussion. The panel fault current changes back to 13.75 kA. The fault all filters can be used to include or exclude single-phase buses from the short circuit analysis. Equipment duty analysis can now be performed for single-phase components. Reports can have the number of phases column added to identify single-phase components. In the short circuit focus, I will select the equipment duty icon in the one-line display of the ribbon. I will also select the equipment duty report to be produced, and I will include the number of phases column. And I will include all devices for the create equipment duty report. I will fault all buses again and press the equipment duty icon to get the equipment duty results. I will select the equipment duty report from the window drop-down. Notice that the report indicates the buses that are three-phase and which are single-phase. Also notice that the report indicates the fault types selected for the single-phase components. Single-phase 3-wire with the line and neutral fault that I had set up, the single-phase 2-wire line to neutral load with a line and neutral fault, and the single-phase 2-wire line to line loads with double line to ground fault. This information will allow verification that the fault types were properly set up for the equipment duty analysis. I will now demonstrate arc flash analysis. I will select the arc flash icon to get the arc flash results shown on the one line for the three-phase and single-phase buses. I can then open the arc flash report, select the labels drop-down, and select print labels for all devices. The labels will be produced for all devices, including the single-phase buses and panels. The single-phase panel is located on page 4. Next, I will show TCCs with single-phase equipment and coordination analysis. I will move over to the coordination focus and then select the BL3 breaker and all of the equipment down to the single-phase line of neutral load. And click Plot TCC to show the TCC. The purple curve is the BL3 incomer breaker for the 3-phase bus. The BL1 is the feeder breaker to the line of neutral 277 volt load. This has been a brief demonstration of a few of the new single-phase features of EasyPower. For more information and complete details of all the single-phase features, see EasyPower Help under the title Single-Phase Modeling. Now we will go over some of the other changes included in the version 10.4 release. The first topic is to review the updates for NFPA 70E 2021. In the advanced arc flash options of the short circuit options selection box, the NFPA 70E 2021 is now provided for both the display PPE description and level selection and the shock approach boundary selection. The references in the PPE description drop-down box are to the PPE levels tables found in the device library. Under PPE levels, and you'll see that there is a new tab for NFPA 70E 2021 with the levels per the incident energy range and the user selectable PPE level text. There's also a second tab for the 70E 2018 levels, including white space where that the PPE level text can be selected by the user as an option. The next topic I will discuss are the following updates to the Revit Integrator interface for EasyPower. There is support for Revit 2021, a new parameter for the Revit fixture families, the ability to import Revit circuit rating data to the trips amps field on a low voltage breaker, panel main breaker, or subpanel breakers, the ability to import the frame size data from the Revit circuit, ability to map demand factor from Revit loads to panel loads in EasyPower, and the ability to map diversity factor for switchgear, switchboards, and panel boards. There are several EasyPower productivity and usability improvements also included in the version 10.4 release. A few of these are: the Find Select feature includes usability improvements to make the feature easier to use and to provide additional functionality. The Find Select dropdown includes 2 new options to select all single-phase equipment or to select all 3-phase equipment. You can also select by an item's ID name. The second item I'd like to talk to you about is the data text block 2. The example shown in the 10.4 release details indicates that the bus electrode configuration can be shown in the data text block 2, as indicated by this at the bottom of the slide. The graphic indicates the programming used to show the electrode configuration in the data text block 2. First, the bus is selected, and then the data text block 2 is selected, and then the text editor is used to program the information that is desired to be shown in the data text block 2. If there were any display conditions needed, they would be added into this field below the text editor. Another example for the second block of text is to indicate bus specifications. similar to that found on design drawings. As shown on this example, logic has been added for the extra detail to be provided for three-phase buses only. The third item I'd like to talk to you about is there is a link now in the program to make it easier for you to contact EasyPower technical support and to provide us with important system information to help resolve issues. When you click on support, you're given multiple support options along with a recap of your important system and program information. I can select support at easypower.com. An email will be produced with the information needed to provide to technical support for your EasyPower software problem. This has been a brief demonstration of some of the new features provided in the version 10.4 release of EasyPower. For more information, please refer to EasyPower Help. Thank you for using EasyPower. We will now take some questions. Yes, Jim, there were several very good questions presented. Two of them were related to the IEEE arc flash calculations for single phase. And I wanted to clarify what the user guide says, and maybe this will shed light on the topic to have you understand better how the single phase equipment arc flash calculations are made. Arc flash, I'm going to read from the page 1375 of the user guide. Arc flash analysis for single phase equipment, whether line to line or line to neutral connected, is performed using the calculated bolted fault current for single phase. The arcing current based on the standard three-phase equations, trip time from the protective device based on the arc current through the device, and the arc flash energy and arc flash bound equations in the standards. The 1584 standard for arc flash analysis suggests using the three-phase equations provided in the standard, and also mentioned that the results will be conservative. And you can find this in some references to the 1584 Article 4.11, and earlier than that in the 1584-2002 Article 5.1. Another question that came up was about the use of single-phase ATS supported in scenario comparison. And scenario comparisons certainly can use single-phase ATS status in terms of being set within the scenario. There are some specific guidelines for single-phase equipment in scenario comparison, and that's found on page 1385 of the user guide, and it indicates that the following restrictions are in place. Single-phase equipment cannot be inserted. Single-phase equipment, and this is while in a scenario, single-phase items can't be inserted or connected, and they cannot be cut, pasted, deleted, or disconnected. And the phase connection of items cannot be changed. So I don't know if anybody else within EasyPower wants to say anything more about that scenario comparison application. There was one other question about Revit 2022 that I didn't have the answer for, so if anybody within EasyPower can provide that answer, please do so. Then there's a new one that came in the existing drawings. When the bus configuration is included and applied, it does not always implement. You have to open and close the equipment node. So in existing drawings, are you saying, the gentleman answering the question, are you saying that this is in pre-10.3 drawings? So I'm not clear on the question. So the bus configuration that I showed to give the bus specs is done in the text visibility section of the tools and options, one line text, and you would select for the bus text block 2, and then you can program in the specifications you want. Are there any other questions?
Certainly, going forward, as questions arise, you can pose them to tech support at easypower.com and be happy to expand on any of these topics that we've covered. Thank you, Craig. I know we have Greg Pergello on the line. Greg, did you want to make any comments? Failing any new questions, I think we're about wrapped up here. We're excited for everyone to download and give the single phase analysis a try, and we're looking forward to feedback. Greg, was there anything else?
No, thank you, Jim. I appreciate it. There's a follow-up question on the comment about bus configuration, but I'll handle that offline.
Okay. Thank you all for attending and look forward to having you join us in the near future. Have a good day.